Study guide for special right triangles. Let's start with number 1. Number 1 says which number satisfies this inequality. And what you'll need to do here is just solve it. So you're going to add 15 to each side. 3x is greater than or equal to 18. Divide by 3. X is greater than or equal to 6. So which answer fits this? A is not greater than or equal to 6. It's negative. It's a negative. D is the answer. Number 2. 5n minus 10 is greater than 26. Write the inequality in words. The answer choice here is C. Does anybody have a question? You just pick out the one that says 10 less than 5 times a number is greater than 26. Make me a list. Okay. 3. Tina can type at least 60 words per minute. And which graph shows this? At least 60. So 60 is a colored in dot, and then greater than that. So that would be answer choice B. Number 4, solve the inequality. C minus 5 is less than or equal to 6. You need to add 5 to each side. C is less than or equal to 11. Color in the dot and shading to the left. That's answer choice B. Any questions on those? Okay, next page, number 5, says negative 1/3 h is less than or equal to 7. How do you solve this one? What do you do to solve this one? You want to get rid of the negative 1/3, so what's the procedure for that? Multiply by negative 3. When you multiply an inequality by a negative, what happens to the direction of the arrow? It switches. So this becomes h, and this is negative 21. H is greater than or equal to negative 21. That's answer choice A. Number 6. Be sure I can see your eyes and your ears. Number 6 says negative 8 is less than or equal to 2x minus 4 is less than or equal to 4. You got a question about number 6 or number 5? Can you wait and ask me when I get through? Okay, good. So I'm going to split this into 2 problems. Negative 8 is less than or equal to 2x minus 4. 2x minus 4 is less than 4. Latham, help me work this one. Good. Okay. And Max, what do we do here? Good. Divide by 2. X is less than 4. So we have negative 2 is less than or equal to x is less than 4. Which answer choice is that? C. 7. Negative 2 is less than 4x minus 10 is less than 6. Split it into 2 problems. Solve each accordingly. Help me solve this one, Bailey. Okay. And over here? So we have 2 is less than x is less than 4. Number 7, answer choice D. Number 8, absolute value of 2x plus 9 is less than 25. Dalton, help me do this one. Okay. Do I work 1 problem or 2 problems? 2. One of them looks identical to this problem except I removed the absolute value bars. The other one, I have to, the stuff under my finger could be 25 or the stuff under my finger could be negative 25. Remember those questions? So if it's negative, remember that the arrow has to change. Then you just go through the solving process. What's 25 minus 9? Divide by 2. X is less than 8. And then over here, what's that, 34? X is greater than negative 34. No, 17, when you divide it 17. So there's negative 17 is less than X is less than 8. It's going to be graphed. At negative 17, it needs to be an open circle. At 8, it needs to be an open circle, and it's shaded in between, and that's answer choice B. Any questions on number 8? Number 9 says solve the inequality. So help me do this one. Taylor? Okay. Alright, so A plus 8 minus 2A plus 24 is greater than 0. Gives me negative 1A and 32. Okay. What happens when you divide by negative 1? A is greater than 32, which is answer choice A. Number 10 asks you to write a compound inequality that the graph could represent, and its D is less than negative 3. Why do I not put an underscore there? Why is it not equal to? Because the circle's not colored in. Then over here, it's greater than or equal to 1. Why is it that that's okay to say greater than or equal to? Because the circle's colored in. Okay, number 11 says all numbers that are at most 9.5, negative 9.5. There's negative 9.5. That can be the most. So that means it's this way. And at least 5.5. So it could be 5.5 or bigger. So it is B is less than or equal to negative 9.5, or B is greater than or equal to 5.5. Solve the compound inequality. When you solve this one, we get X is less than or equal to negative 5, or X is greater than or equal to 2. It goes with A. Any questions on that? Okay. 13, we solved it yesterday. It is a Pythagorean theorem question. A squared plus B squared equals C squared. And we let A be 5, and we let B be 12. And we solve and we find that C is 13. Do you have any questions on how to do that problem? Was that the one that was bothering anybody? Okay, let's go to the next one. The next one is the same kind of problem. What's different though? There's one thing that's different here. What is that? You're solving for B squared. You're solving for C, for B, so you know C. C is 13. So you get A squared plus 12 squared equals 13 squared. A squared plus 144 equals 169. Subtract 144. A squared is 25. And what do you do at this point? I think everybody kind of can get here and doesn't have any trouble. I just want to be sure you know what's the next step. Take the square root of each side. And the square root of A squared is A, and the square root of 25 is 5. So that's our answer to 14. Do y'all have any questions on 14? Okay. 15. Here's number 15. Find the length of the missing side. Find the length of the missing side. So you're looking for C. So you set up this and you let A be 14 and you let B be 6. You square 14 and get 196. Square 6 and get 36. Add them together. When you take the square root of 232, it's not one of those nice pretty numbers that we know the square root to. So we have to break it into factors. So what we want is a factor of 232 that's on the list of squares. And what number would that be? 4. And the square root of 4 is 2, and the rest stays under the radical, so it's 2 square roots of 58. Okay, what about 16? Latham, help me do 16. Okay, it's a 90-degree angle, so it makes it a right triangle, right, Latham? And if you're looking for one of the sides of a right triangle, what is it that you can use? It's something that you've known about for a couple of years. It's not one of the brand new things I taught you this year. We've used it on the Pythagorean theorem, and that says a squared plus b squared equals c squared. So in this problem, you have to pick out what a, b, c are. So tell me what you know about that. Okay, and then it really doesn't matter whether you let it be a or b. So 7 squared plus b squared equals 11 squared. So 49 plus b squared is 121. Subtract 49. What's 121 minus 49? Okay. What's the next step, Latham? Okay. Now what about 72? It's not a perfect square. Is there a number on the list of squares that goes into 72? Is there another one? 9. Is there another one? 36. It doesn't matter which one you use, but the bigger one, if you use the bigger one, you only have to do this process once. So let's break it down into 2 and 36. Answer to 36 is 6, so this is 6 square roots of 2. 17 says, in triangle ABC, angle A is a right angle. Angle B is 45. So what does angle C have to be? 45. Find BC. If your answer is not an integer, leave it in simplest radical form. What do you know about a 45, 45, 90 triangle? Write this on your paper. I'm just going to give you just a random example, okay? If this side is 7 and this side is 7, because in a 45, 45, 90, it's isosceles, right? You agree? If two angles are equal, then two legs are equal. Then you can do the Pythagorean theorem on this. 7 squared plus 7 squared equals c squared. 49 plus 49 is c squared. It gives me 98. And then when I take the square root, does 98 have a factor that's a perfect square? 2 and 49. So this is 7 square roots of 2. Okay? Questions about this? So this is just a random example, but every 45, 45, 90 triangle is going to follow this same pattern. So if this side's 11, then you know that this side's 11. What do you think we'll get when we do the Pythagorean theorem? We're going to take the square root of each side. The square root of 2 times the square root of 121. So what do we get? 11 square roots of 2. In every 45, 45, 90, the hypotenuse is the leg length times the square root of 2. It happens that way every single time. So let me draw one over here. This is 50. What's this side going to be? 50 square roots of 2. Okay? Let's look at the next one. Let's look at 18. Now 18 is different because it says find the length of the leg. They're giving you the hypotenuse and they're wanting you to find the length of the leg. Now tell me something. What if I had this problem? What if I had a 45, 45, 90 and I told you this was 27 square roots of 2? What would the size be? 27, right? If I draw another one and I tell you this is 123 square roots of 2, what's each side? 123. Do you have that down, that relationship? Yes? This means yes, this means no, and this means lost. Which one? You with me here? Okay. Now, in your mind, all you did was throw away the square root of 2. I mean, I know that's what you did. That's just what you did. You just broke it off and just left it somewhere else. But technically, this is what happens. You take that number and you divide it by the square root of 2. And that's how they eliminate, that's how they reduce away. Well, that works great as long as square root of 2 is on there because it makes your life easy. You're going to do the same process here. I don't know what this number was in this box, but I multiplied it by the square root of 2 and I ended up with 24. That's what we've been doing, right? Whatever number is out there, multiply it by the square root of 2. We've been writing something times the square root of 2 because it's not been being a nice integer. Well, now what do you think you need to do to solve for the box here? Divide by the square root of 2. So whatever was in the box is 24 over the square root of 2. Well, you can't do, that's not 12. It's not any kind of method of 12. We also have run up on another problem. I can't allow that radical in the bottom of a fraction. What do you do to fix that? Multiply by a version of the number 1. What version of 1 do you want to multiply by? Square root of 2 over square root of 2. What's the purpose? Why? Why we pick that number? How am I going to know what to pick when I'm doing it all by myself? Well, you want to multiply 2 by something so that when it gets an answer, it has a square root. So if I multiply 2 times 2, I get 4 underneath there. And I can take its answer. Okay? What's 24 times the square root of 2? It's just 24 times the square root of 2. Now, what's the answer to the denominator? 2. And I can simplify that, and it's 12 square root of 2. Okay? Write down that process. Be sure you know how to do it. Put a big star by 18 because that one's a little tricky, okay? I don't think you're having trouble with 17, but 18's a little bit different. Okay, let's look at 19. Find the length of the missing side and the triangle. Write your answers as integers or as decimals rounded to the nearest tenth. Okay. So, here we go on this one. What is 6? What is 6? What does y have to be? This is 45. This is 45. So, these have to be congruent and y has to be 6. Okay. What about x? It's 6 square roots of 2. But they want me to write it as a decimal. So on my calculator, I'm going to type in 6 times the square root of 2 and round it to the nearest tenth. And so what's that going to be? 8.5. Number 20. It's another 45, 45, 90. Find the value of the variable. If it's not an integer, leave it in simplest radical form. Now you tell me, is this one going to be another one like number 18? What made 18 kind of difficult? They gave me a hypotenuse, and it didn't have a square root of 2 attached to it. So, here we go. I do not know what this number is, but I know that if I take that number and I multiply it by the square root of 2, I'm going to get 9. I'm looking for the leg, and I know that when the leg is multiplied by the square root of 2, I get 9. So x times the square root of 2 is 9. What's the next step in the procedure? So x is 9 over the square root of 2. In decimal form, I could, and it'd be easy to do, but that's not what they said this time. They said I got to fix the integer, I got to fix the radical part. Is it okay to have a square root in a denominator? No. You've got to multiply it by something so that the denominator over here has an answer when you take the square root. So what's the easiest thing to turn that into? 4. So it's going to be multiplied by the square root of 2 over the square root of 2. We get 9 square root of 2 over 4. 4 is the square root of 2. So this is my answer for that one. 9 square root of 2 over 2. Okay, there's a relationship in every 30, 60, 90 triangle. Who remembers what that is? Well, it's kind of like Goldilocks and the Three Bears. Every small angle is across from a small side, and the large angle is across from the long side, and the hypotenuse is across from the right side. So 30 degrees is here, so over here is the short side. 60 degrees is here, so across from it is the long side. And across from the right angle is the hypotenuse. How are these things related? Who remembers how they're related? Like if I told you the short side was 5, is there another side that you could tell me right off the bat? What's the long side? That's the hypotenuse. And this one's 5 square root of 3. That relationship is the same in every 30, 60, 90. If you know the short side, multiply it by the square root of 3 to get the long side. Multiply it by 2 to get the hypotenuse. Okay? So in this picture, on 21, what did they tell me? Here's the 60. This is the 30. Which side did they tell me when they put the 7 over there? Is it the short, the long, or the hypotenuse? It's the short because it's across from the smaller angle. And the side that's labeled here is the hypotenuse. So what do you do to find x? It would be 7 square root of 3. Could you do the Pythagorean theorem? Yes. But they really want you to use that relationship among the sides to find that. Now, let's look at 22. At 22, it's a 30, 60, 90. And which side did they give you to start with? The hypotenuse. And the hypotenuse is how much bigger than the short side? What's the relationship between them? Twice. So if this one's 20 square roots of 3, how many square roots of 3 was this one? 10. Now, what do you do to find the long side? Multiply the short side by the square root of 3. So 10 square roots of 3 times the square root of 3. What's the square root of 3 times the square root of 3? 10 square roots of 9, which is 3, which is 30. Okay, 23. The first thing you have to do is tell me which side is labeled. Is it the short side, the long side, or the hypotenuse? Okay, short side. When they give you the short side, it's usually an easier problem. What's the relationship between the short side and the hypotenuse? Times 2. So the hypotenuse has to be what? 24. What's the relationship between the short side and the long side? Multiply by the square root of 3. So this is 12 square roots of 3. $24. Which side did they give you to start with? Hypotenuse. If the hypotenuse is 16 square roots of 3, then how big is the short side? 8 square roots of 3. And what's the relationship between the short side and the long side? You multiply it by the square root of 3. So 8 square roots of 3 times the square root of 3 is 8 times the square root of 9, which is 3. So it is 24. Okay, 25. 25 says you have a 30, 60, 90. Hypotenuse is 14. Find the perimeter. If the hypotenuse is 14, what's the short side? 7. And what is the long side? And how do you find the perimeter? 7 plus 14 plus 7 square roots of 3. The square root of 3 acts as a variable here. You could add things that had the very same radical part, but if they do not have the same radical parts, you can't add them together. So the only things we can combine here are the 7 and the 14. That gives me 21 plus 7 square roots of 3. Ready for 26? Find the area. What shape do we have here? What would you call this? Rhombuses have all the same sides. How many sides does it have? 4. It's a quadrilateral, right? It kind of looks like a parallelogram, but they really hadn't told me for sure. What's the area? How do you find the area of a parallelogram? What's the formula? It's triangle. It's real simple. How do you find the area of a? It's the same for a rectangle, a square. Length times width is what we say. That's what we teach you to say first, and then we change it to base times height because we get a little more technical. Let's talk about base and height. The base and the height are going to be perpendicular to each other. Okay? That's why we change from length and width when we get to more complicated problems. So which two pieces in this picture represent the base and the height? Because they give you 3 numbers and you only need 2 of them. 30 is your base, 36 is your height. So this is 30 times 36, which is 1,080 inches squared. How do you find the area of a triangle? What do you do to find the area of a triangle? 1/2 the base times the height, because it's cut in half. It's a rectangle or a parallelogram that's been cut in half. That's why the area formula says just take half of it. So in this picture, which one's the base and which one's the height? We'll call this one the base, call this one the height. So it's half of 2.1 times 7. And I get 7.35 centimeters squared. 28, same type problem. Area is 1/2 the base times the height. So it's 1/2 of 14 times 3. So it is 21 yards squared. Any questions on these? Do you not know the formulas? Do you know the formulas? You know the formulas or you don't? You need to know. You need to know the formulas for a parallelogram, for a triangle, for circles. You ought to know those. You shouldn't have to look those up. Now, the more complex ones we get into later on, but of course, but for those, you should know them. And in this chapter, I think you're going to have to know trapezoid and kite, too. Okay, now, they say the area of the parallelogram is 420 centimeters squared. The height is 35. Find the base. So, this is where you just need to use the formula and substitute the numbers in place of whatever they represent. What does 420 represent? What is base? We don't know. What's height? Now, what do you think you ought to do? Divide. And the base is 12 centimeters. Okay. Number 30. Angle A is a right angle. B is 45. C has to be 45 as well. Find BC. If your answer is not an integer, leave it in simplest radical form. So, what's BC? 12 square roots of 2. 31. Find the length of the leg. What kind of triangle is it? First, you have to figure out if it's a 45, 45, 90 or a 30, 60, 90. Okay. The hypotenuse is 18. So, in this kind of problem, I take that and multiply it by the square root of 2 to get the hypotenuse. So, what do we do next? Can I leave it like that? I got to multiply it by this. It's called rationalizing the denominator. It's getting rid of the radical. So I get the square root of 4, 18 square roots of 2. It's 18 square roots of 2 over 2, which turns out to be 9 square roots of 2. $32 is the same kind of problem. $32 is the same kind of problem. The hypotenuse is 5. What are we going to do to find this? What do you think we ought to do? In a 45, 45, 90, normally you take the leg length and you multiply it by the square root of 2 and you get the hypotenuse, right? That's what we've been doing. So that gives me an equation. How do you solve it? So we get 5 over the square root of 2. Can we leave our answer like that? No, we got to multiply it by the square root of 2 over the square root of 2, which is 5 square roots of 2 over the square root of 4, which is 5 square roots of 2 over 2. $33. The length of the hypotenuse in a 30, 60, 90 triangle is 8. Let's get this drawn up here. The hypotenuse is 8. They want us to find the perimeter. If they tell you the hypotenuse, is there one of those sides that's real easy to find? Short side. What is it? Okay, good. And now that you know the short side, can you come up with the length of the long side? What's this? Now to find the perimeter, okay, you can only add the ones that are alike. If it has a radical attached to it, it's not like the ones that don't. So this is 12 plus 4 square roots of 3.